By the end of this lesson, you should be able to use an equation for the rate of change of a quantity to find the total change of that quantity. Let's start off with the interpretation of some symbols. So if you have an equation R of t for the rate of change of a quantity, and this is really key, it has to be an equation for the rate of change. Typically it's going to be in terms of time. Then the integral from a to b of R of t is what we call the accumulation. Or the net change overall. Of that quantity from time t equals a to t equals b. That time piece is important, shows up a lot on the AP test. The units are the numerator of the R of t units. So for example, if R of t is people per hour, then the integral of R of t is going to be people for units. 1 over b minus a, the integral from a to b of R of t. This is different. This is the average of R of t, or the average rate of change of the quantity. The units are the same as R of t. And finally, R prime of t, I should put in here average rate of change of the quantity from t equals a to t equals b, same as up there. R prime of t is the rate of change of R of t, which gets a little bit long when you think of it as the rate of change of the rate of change. And then the units are R of t's units divided by the t units. Because this, remember, is slope, so we're going to do basically the y-axis divided by the x-axis. Okay, let's go ahead and do some problems. Calculator is required for all of these. The rate at which people enter an amusement park can be modeled by the equation R of t equals negative 720 times pi over 6t minus pi over 3 plus 720. And that's when t is between 0 and 13. And what this means is it means that t is the number of hours since the park opened at 9 a.m. R of t is in people per hour. Okay, here's our first problem. According to the model, how many people have entered the park by noon? Round to the nearest person. Okay, so the key thing to realize when you're looking at this is that we are given a rate of change. It says right here in the problem, the rate at which people are entering. So we're given R of t in people per hour, and we're asked about the number of people. This means that we're being asked about the numerator of these R of t units. And that's a pretty good indicator that we're going to be talking about accumulation, that we're going to be talking about the integral. So we want to know the accumulation of people from t equals 0 when the park opens to t equals noon. So let's see, so 9 a.m. is t equals 0. 10 a.m., that would be t equals 1. 11 a.m., t equals 2. 12 noon, t equals 3. So accumulation from t equals 0 to t equals 3, that's the integral from 0 to 3, r of t dt, or the integral from 0 to 3 of negative 720 pi over 6t minus pi over 3 plus 720 dt. Now the nice thing about this is that we can just pop it in our calculators. So this is going to be Math 9, which is finite integral, expression, variable, lower bound, upper bound. So, grab our calculators, go to Math 9, there's finite integral right there. So we can put this in using whatever variables we want, as long as we just put what variable in that we're using. So negative 720 pi divided by 6, make sure you're in radians. I'm just going to use x because it's sitting right there for me, minus pi over 3, close parenthesis, plus 720, comma my variable, which is x, comma 0, comma 3. And there we go. Now I'm going to round to the nearest person. 2,725 people. And that's an accumulation problem. It's very, very, very important to have these units. Always, 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 always going to be critical for accumulation. Oftentimes, having the units is worth about as many points on the free response questions as having the mathematics correct. So continuing with that same problem, what is the average rate at which people enter from when the park opens until noon? Okay, so remember average value. That's 1 over, subtract the bounds. Let's see, from when the park opens, we said t equals 0 till noon. That was t equals 3. So that was that same equation again. So we have 1/3, and then that same 2,725 people. So I'm going to take my answer from before, I'm going to divide by 3, and I get 908 people, again round to the nearest person. Now let me be very careful with those units. Average rate at which people enter, so that means it's the same as my original R of T units. R of T was in people per hour, so that's 908 people per hour. At 10 p.m., the gates close. And people can only exit. At 10 p.m., there are 900 people left in the park. And the rate at which people leave is given by L of T equals 1800 minus 1800T, where T is the time in hours since 10 p.m. How many people are left in the park at 10:30 p.m.? Okay, so since T is the time in hours since 10 p.m., 30 minutes is half an hour, so that means that T equals 0.5 right here. The key thing to realize with this problem, and where it's different than the previous one, is that here we have 900 people left in the park, right there. So that means we start with 900, and then the rate at which people leave. We are taking away the accumulation. So this means that the number left is the number at 10 p.m. minus the number who leave. So this is the only accumulation part. You have to really, really watch out for these problems if there's some sort of initial condition, basically. So the number left, the number at 10 p.m., we're told that's 900 people. The number who leave, this is accumulation. Of L of T, because this is the rate at which people leave, so the integral is the number of people who left. So from 10 p.m. to 10:30, And we have the actual equation for that, 900 minus the integral from 0 to 0.5 of 1800 minus 1800t dt. Once again, this we can just stick in the calculator. So math 9, 1800 minus 1800t, or x, whatever variable you want to use, from 0 to 0.5. And we've taken the integral, so now instead of people per hour, we have people. 900 minus 675 means that there are 225 people left.